All right, everyone. I am here with Nir Bar-Lev. Nir is the CEO and a co-founder of ClearML. Nir, welcome to the TWiML AI podcast.
Hey, Sam. Thank you so much. Really happy to be here.
Hey, I'm super excited for our chat. We've known each other for a bit now. I think we first met at, it was like a GTC event or...
Exactly. The last GTC that was not online, I think.
Yeah. And we've had some really interesting conversations about the MLOps space since then. And so I'm looking forward to chatting with you here. Before we do that, I'd love to give our audience a bit of an opportunity to learn about you and your background and how you came to co-found ClearML.
Yeah, definitely. So started actually at one of the IDF Elite Technology Units and worked my way through there, became an engineer, worked as an engineer for about 8-9 years in financial systems, ERP systems, those kinds of systems, mostly larger companies. Then actually made a transition to more of the product business roles, business development, product development, sales. Went on to get an MBA at Wharton, and then I joined Google. Slightly after Google had acquired Android, and so that was a super cool time. Was one of the founding members of the mobile team at Google. Worked on the strategy with Andy Rubin, who's obviously an amazing guy. Built Google's voice recognition platform, which is kind of interesting. We built it that old technology, and now it's completely revamped based on AI. And then moved to Israel to help build the Google R&D Center, which is about a 1,600 person strong R&D center, one of the biggest for Google in the world, outside of the US. And then spent my time, mostly roles in Europe, Middle East, and Africa, led Google Analytics in Europe, led search advertising in Europe, which was a business of about $10 billion annually at the time. And then ended up as a general manager for mobile payments for cash-based economies. That was my last role at Google. And then looked on to what to do next. That was about actually it was a decade at Google. And at the time I was at a leadership getaway with the founders of DeepMind, which Google had acquired about a year prior to that. And had some really interesting discussions with the founders there, and about the potential of AI and about the challenges. And I don't know if you recall, there was a really interesting blog post that Google had came out with at around that time about how they improved electrical consumption in their data centers,
In the data
which is a
center,
huge
about
number.
40% or so.
Exactly,
Yeah.
and they did that with AI. Now, that got a lot of attention. But what wasn't known outside was that building that initial model took 3 weeks. Building a prototype to check it out, just validate it in one data center, not a working product, but a prototype, took 3 months. Rolling it out as a product, over a year.
Wow.
And that's exactly, that was Google. And obviously, that really set the stage for, AI. You may have the best data scientists in the world, and building the model is, could have amazing results. But if you don't know how to actually put it into production, it's not going to provide any value. And really, that's MLOps, right? I mean, it wasn't called that way in the past. It has been for about a year now, right? And I felt like, this is something I want to get into. And so I joined two partners, my co-founders, amazing technologists. One of them was really one of the first people who started deep learning and computer vision in the academia in Israel. And we started on a journey. We didn't call it MLOps at the time, but that's really essentially what we were doing.
Yeah. Wow, there's a ton in there. Do you remember the year? I'm trying to keep myself from going down the Andy Rubin rat hole because I don't think that's what we're here to talk about, but he's quite a controversial figure.
The year for what? For that blog post?
The year for the blog posts.
I'd say circa 2015.
Mm-hmm.
You know,
And
maybe a year earlier. Yeah.
would you guess that that timeline? Yeah, I think we're all working on that timeline in the MLOps realm. I'm wondering if you'd venture a guess as to what it would look like at Google today.
Um, so I have a bunch of friends. Obviously, Google. It looks very different. I mean, obviously, Google is one of the world leaders in the space, and I think that Google was uniquely positioned to understand both, the power and opportunity inherent in AI, but also the challenges that would be needed to surpass to be able to put it in production. And they also had the capabilities, right? They had data scientists and they had engineers. Um, and at the time they called it Google Brain, which was the
Mhm.
team there, and they had a lot of manpower and a lot of brain power going at this from many directions. And they had frankly, the resources to build this. And probably makes sense if you think about the scale that they're working at. But for 99.9% of the other companies, I'd venture to say it's not within their core competency to build the scaffolding for AI.
Yeah.
A lot of them you probably want to have data scientists because, you know, if you want to be competitive in virtually every industry today, you have to integrate AI into your business. And so, that you don't want to outsource that. But building MLOps,
Hmm.
that requires a lot of expertise, specifically on, um, that frontier between the science and the engineering,
Hmm.
and being able to take the science and make it engineering, and that's what we're doing.
Yeah. Yeah. I think what I was looking for in that answer was, um, kind of seeing Google as like the Google's going to be the best that Google's going to do this as good as anybody else. And so
Oh yeah,
if they're able to cut the process down 90%, that's probably the best. That kind of gives us some asymptotic bounds
right,
around how good
right,
good ML ops allows you to be. If it only
yeah,
impacted them 40%, then that says that there are fundamental challenges in the ML lifecycle that ML ops, um, isn't able to facilitate. And we've got lots of uh, anecdotal figures. I'm sure you do as well from your customer engagements. But I was curious if you had, you
from
know,
Google.
if from Google. Yeah, yeah.
Yeah, unfortunately, I don't have those numbers from Google.
Yeah,
It's been a while, and that's kind of like sensitive numbers to share with an old friend.
yeah, yeah, absolutely,
So I don't
absolutely.
have those.
Well, that's probably a good segue for us to dig deeper into the numbers and experiences that you do have and can share. Maybe good context for that is for you to share a bit about what ClearML is up to and kind of how you approach helping folks with ML ops and some of the ways that you differentiate yourselves from other folks.
Right. Um, so when we think of MLOps, there's a lot of things that go underneath, right? And the way we think about it, and again, it's not. I mean, there may be other smaller pieces, but generally speaking, you've got everything that has to do with getting the data into your system, and then you have what we call experiment management or experiment tracking and logging, which is how we think about the day-to-day of data scientists, how they manage their training experiments, how they can compare, log experiments for reproducibility, track results, and be able to. I mean, that's basically their development environment. Then you have everything around orchestration, because literally from day one, if you're developing something, once you get beyond something that you can run on your own computer, you need to run big workloads on lots of data, and you want to be able to do that effectively on cluster. And so you have the whole orchestration piece. How do you actually get that to work really well, because AI workloads are very different from regular software workloads. We can get into that later if we want, but that's another piece. Then you've got everything around data management, versioning, tracking, what has recently been called feature stores, which is part of it. Data pipelining, and then you even have beyond that something that we also are, providing is what we call hyper data sets, which is not only do you want to be able to have data lineage and versioning, and be able to manage your features for training and for deployment, you also want to be able to have in-depth analysis of the data at hand, right? Where are my data biases? Where are my skews? How do I manage those? Think of it as like BI for AI data. And so that's another piece in MLOps. Then you've got the whole piece around deployment and then monitoring, right? So how do you effectively deploy models? And it changes because there's deployment on the cloud, which is oftentimes machine learning, lots of models concurrently, but then you also have deployment on the edge. Think of all the use cases around deep learning, especially whether it's computer vision or sensor analysis, speech recognition, etc., that really live on the edge. And the edge could be, data center. It could be a robot. It could be obviously a autonomous vehicle, or it could be, a small camera. So managing that, and then monitoring the models in production, in inference, to identify model drift and concept drift, which is something that we have to live with in AI. And then that feedback loop, right? How do you actually connect that back together to create a situation where you could connect data coming in from the field with the original data set they use, balance that, retrain that, and then send up optimized models, ideally automatically. So that's that's pretty much what MLOps is about. And what we're aspiring to do is to provide a very comprehensive solution. That's different from many of the companies out there that try to focus on a very specific piece.
Yeah, I remember
But
one of our first conversations was digging into this, what I call the wide versus deep paradox in the ebook that we published, the definitive guide to machine learning platforms. And the way I characterized it at the time was you've got a set of vendors that are trying to quote unquote own the MLOps workflow and support data scientists and ML engineers end to end. And then you've got another set of vendors that are trying to go deep in specific feature areas. Like I'm going to go super deep in experiment management. And what I thought was this interesting paradox was, the folks that were advanced enough to need an end-to-end platform had often invested heavily in some deep feature. Either they built it or they bought it. And folks that knew enough about the problem that they knew they needed a deep solution, often had gaps, in their end-to-end pipeline, so that the end result of this was that the deep vendors were kind of pushed to go broader, and the broad vendors were pushed to go deeper, and it just created a ton of confusion in the marketplace. And you see, lots of these kind of point solution vendors gradually expand the offering over time. And from our early conversations, it sounds like you've gone deep into specific areas over time. I'm curious how you think about that, wide versus deep now, many months since the last time we talked about it.
Yeah. I don't think there's one size fits all. I think that, and I also think that what you alluded to is really right. Look, MLOps is ultimately we and all the companies in the space are providing tools for people to build stuff on top of. Right? We're not providing applications, and we're not even providing, tools for business analysts, sometimes called data scientists, but doing business analyst kind of work. We're building tools so they can build services and products on top of it. And when you do that, one of your kind of competitors is your customer themselves, right? Because you're putting this to data scientists and ML engineers who love to build stuff, and so I think the trick is to how to provide them something that makes sense. Each one of them is going to have each team is going to have their own different opinions on what they want to see. From our perspective, how we think about it. Let's look at that way. And again, I don't think it'll fit everyone's, right? So the first point is we think that in AI, you've got three moving pieces. You've got the models, you've got the data, and you've got the code, which means that integration is going to be really, really hard. Integration is hard in computer science, period. But when you have three moving pieces rather than just code, that's going to be even tougher. And so if you have to deal with multiple vendors, it's not just integration on the technical level, it's integration on the procurement level, financial level, operational level, etc. And so we think that if, as a vendor, right, you can provide a solution that, let's assume, isn't the best in every single one of those pieces, but it provides 90% of the value, you're probably, that versus the cost and the burden that you're saving for the customer on all those integrations, we think is worth it. But we didn't stop at that. We also built something that's very modular, because for two reasons. One, because we believe in what we call buy and build. And so you as a customer, we believe, will want to buy the scaffolding, the platform, because you're not an expert in that. You want to make sure you buy it from a vendor that's going to keep making sure they have the best technology at all times. But you're building, because you're building your specific solution on top of it. And so a paradigm like that requires really robust APIs, etc. But if you do computer science engineering correctly, you're going to build modular, robust pieces even between our modules. And so that fact creates a situation where, at least for our platform, it's not an all or one thing. It's not, you don't have to use everything or nothing. You can actually use pieces of it and pieces from other vendors, or pieces that were built in-house. Again, because our competition or alternative could be something that they've built in-house. And we see that a lot. We are in multiple customers where we're not providing the full platform. They're using us for certain pieces. They're using inbuilt solutions, and then some of them are using some of the other companies and vendors out there.
Yeah, this was one of the ideas that I found quite interesting in your TWiMLcon presentations. We think of it as a mutually exclusive set of options: buy versus build versus buy. But a lot of the way you discuss the way you deliver your solution, and in the case study joint presentation with your customer Theodore, was focused on how actually buy and build coexist in their world, and what the different pieces were, where there were other open source and commercial products that all together came to create were put into play to create a solution for them.
Exactly.
I guess one question that comes to mind then is, if you're taking that approach, how does that avoid these integration costs that are the big problem?
Well, so first of all, one point I think it's worth mentioning, if we didn't, when we say buy and build, we're open source, so the buy is just using us rather than building it on your own. That's what we mean by buy, basically taking our solution. But that's a great question. There is no single answer, but what we do find is that a significant portion of our customers tend to use more than one module of ours. And the more that they use us over time, the more they tend to use more modules. So you're right, we may not be saving all the integrations. but we're saving some. So rather than using, let's say, on the extreme 5 vendors or 5 different solutions, whether they're inbuilt, they're going to end up using 2, right? And so there is saving there. But you're right that we don't save everything, all
Yeah.
the integration all the time.
I imagine that there are ideas like data structures or even kind of API philosophies around which there's some efficiencies, like you learn it for a system, and even though the modules are different, um, you're learning a kind of a way of thinking about things, and there's some efficiency in using modules in the same out of the same product or project, even if you have to do some integration between them.
Yeah, that, and also, we are also working. We're part of the AI Alliance, and for example, we published a blog post with Pachyderm on integration, and there's actually a GitHub library on integration between ClearML and Pachyderm. So, so to the extent that we can help support lowering the bar in terms of the integration, even with the ecosystem, larger ecosystem, even if it's not our modules, we'll do that. But you bring a correct point. I don't think that there is an answer, right? A definitive answer to this. It's always going to be, we're playing in the gray area. It's not,
Mhm.
some are going to use just us. Some are going to use, not choose to use us and choose, other vendors or internally built solutions, and a significant percentage are going to use, us for a bunch of things, and so lower a significant part of their integration cost, and still decide that for a certain piece, for their specific use case, it's worth using some other vendor or some internal solution, and then they will be willing to pay that price for that specific integration.
Mhm.
Um, and within that, we obviously try to lower the cost of integration as much as we can.
Mhm. Mhm. Do you have a sense for among the modules you have, or the even more broadly the elements of the end-to-end workflow, where you're seeing folks you know buy versus build, use what you have versus use their own versus use another product?
Um, so experiment management today is pretty much a buy, right? Again,
Mhm.
buy could be using open source, it could be using us as an open source, it could be using MLflow or weights and biases or the other solutions.
Mhm.
But pretty much very, very rare these days to see a company building their own solution around experiment management.
Mhm. Why do you
Where
think that is? What?
um, I think that experiment management, for a number of reasons. One, it's the first thing that data scientists actually interact with, and before you actually even get to the ML engineers. And data scientists are not engineers, and so they would actually prefer to use something rather than build. It becomes difficult for them, and so only in cases
Mm.
where you have an ML engineer say, no, 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 I want to build this. It becomes like, why would I want to build this? I'm a data scientist. I want to focus on the science.
Mhm.
Um, and so, hitting that with data scientists as the first problem is one thing. I think that it's the easiest to get started with. Again, if you think about the life cycle of a team or a product, right? Pipelining, deployment, and data management. Although we think it's the most important piece by far,
Yeah.
still, it's for many reasons it gets less attention. Um, experiment management just becomes the easiest thing to default to,
Mhm.
and there's at some point, right, if you think about the maturity of the industry, you get to a point where if you go online to start looking for things to build or how to build it, you'll very soon see, why are you doing this, right? Experiment management, here's a list of tools, just use them, right?
Yeah.
And so you realize, I'm not going to do this. I'm not going to make that mistake.
Mhm.
Then you get to other things that, today I'd say you still see companies tooling together stuff, but they do less and less of what they've built. Although we're seeing a lot of companies that started 3 years ago, 4 years ago, where there were very, very few solutions, if any, out there, and so they had to build something. And so now they're faced with a dilemma: do I continue to support what I've built, right, sunk cost or whatever you want to call it, or do I switch, because there's switching costs, they're real switching costs, right? They have something that's working for them, and so that's the dilemma that they're in.
Mm-hmm.
I think that over the next 2, 3, 4 years, it's going to be a situation where very, very few companies are going to build things on their own. It's really just going to be a decision: do I take an open source, or lots of open source pieces and combine them together, or combination with other vendors, and then build my specific thing on top. But I don't think we're going to see anyone building scaffolding, the real scaffolding of MLOps, unless they're a Google or a Facebook, which for them makes sense.
Mm-hmm. Mm-hmm. How do you see things shaking out in terms of folks using a software-based approach versus just taking whatever the cloud vendor of choice has to offer in terms of a platform?
What we're seeing today still is that the solutions provided by the cloud vendors have two big disadvantages. One, which I think is going to be harder for them to shake off, which is that they tie you into their cloud. And and I think that certainly a lot of other vendors are making sure that at least we're agnostic, right? ClearML, for example, works on any cloud, right? Any one of the big three, but also many other clouds on-prem, or any kind of deployment that you like. And so that's one big thing, and it's important because companies don't want to be tied to a cloud vendor at times. And at least for a lot of use cases, again, mostly on deep learning, you're talking about hybrid setups where you've got data coming in from the edge, you've got to do some processing at the edge, and so making it 100% cloud is a problem. And there, in those situations, even if you decide that you're going to go with Azure, for example, right, for the next 10 years, you still have a problem. How do you deal with MLOps on the edge? That's one problem. The second thing is, at least to date, the MLOps solutions that are out there by cloud vendors, and this is, I'm going to quote my customers who come to us, is that these solutions tend to be very shallow, and very opinionated. And so they will work really, really well if you're using it exactly the way that the engineers at X cloud vendor company designed them. And they're great engineers, but they design it in a very specific way, and it's very shallow, and you can do that really well, and it integrates incredibly well with their underlying other pieces in the cloud. But then if you want to do something slightly different for your specific use case, then a lot of times they're going to hit walls.
Mm-hmm.
And we have customers who've come to us exactly for that reason. Now, this is something that cloud vendors are going to probably work at, and so we're going to have a more challenging competitive landscape later on. But that's that's a natural progression of markets.
Mm-hmm. You mentioned some of the work your customers are doing. We did have the opportunity to hear from Ariel at ClearML, and again, I mentioned Theodore Doughton from Theodore. I'd love for you to kind of give us a snapshot of either what they're up to, or another customer that comes to mind that's doing some interesting things. Who's pushing the envelope out there?
Who's pushing the envelope? So we have one customer, another startup, that has built a system for analysis of X-ray machines at airports, and for security. And they're they're a very small team, relatively speaking. But in a matter of a couple of years, they've built a solution that is by far better than anything else out there. And they're they're pushing the envelope on how they use MLOps. We're very, really proud that they're using us end to end. But they've built a system where they can literally deliver models that are tailored for each X-ray machine specifically, because no X-ray machine is exactly the same as the other. And if you look at some X-ray images, if the gun is really nicely put flat out against the screen, you'll see it. But what if it's in an angle where you're seeing the side? It may look like any one of 100 different things. And so accuracy becomes really super important. And even the slightest deviations between machines can affect that. And they've been able to use us to deploy a system where they automatically can optimize models for each specific customer and each specific machines based on the performance of the different models. Obviously, they look at the edge cases where, for example, the model isn't absolutely sure about what they found, and they use those to retrain models. But it's 95 to 99% automated, and that's we think that's amazing, and we think that's where everyone's going to get to at some point, where you can deliver what we call overfitted model, but in a good way for each single sensor in the space, or for each single model for doing a very specific, I don't know, identifying the right ad for a very specific person, right? Obviously, privacy issues aside. So that's one customer that's really pushing the envelope.
It's an interesting way to think about that idea, overfitting the just to replay that. Overfitting, the problem with overfitting is that it doesn't generalize, but if you are overfitting to any particular sensor or device or something, you don't need it to generalize
Exactly.
because you've built a model for that thing. You
Exactly.
want
You
it to
want to build.
generalize, I guess you want it to generalize in one dimension, like in the dimension of the data, the distribution, but not you're also able to have it very well fitted to the specifics of your sensor.
Yeah, exactly. So usually what happens is you want to build a generalized model initially, and then you want to overfit it specifically on some dimensions for each one of those, cases. Again, it could be by sensor. It could actually be for different things. You can even think of a clouds situation where, you're delivering a model to identify, do prediction on, I don't know, whatever, weather, right? And you can overfit the model for San Francisco, which has a very interesting weather pattern, and overfit that for every different city, right? Similarly for any use case. And by the way, you can also overfit for the data. We have a customer doing security cameras, and they gave us a test case initially where we looked at how to build this, basically build a system that supports multiple models, right, for each camera. And there was a situation where there was a camera pointed at an entrance to a large train station, and the entrance had these glass windows, and there were reflections there. That has a very particular set of specifics in terms of the data. You're always going to get images that may have reflections in them, and so you can actually even overfit for that on that dimension as well.
Interesting. We've talked quite a bit about devices and distributed sensors, and in our recent kind of pre-conversation, the whole topic of federated ML came up, and it's an area that you're doing some interesting stuff in. Can you elaborate a bit on what you're doing there?
Yeah, so we're doing two big things in federated learning. And so if you think about federated learning, the theory is basically saying, how do I train a single model using data that's located in multiple locations, which I cannot gather together to one location? And so I have to solve the obviously the compute problem, and because I need to train that on the edge, but then I have to somehow connect the data to a single model. In order to do that, theoretically, what you would need to do is you basically run one epoch, take all the feature scalars, send them back to one location, combine them together, send them to then redistribute them, do that again, right? If you do that every epoch, obviously it's going to take forever, right? Because when we train models, we do this billions of times, right? And so think of the network latency and etc. That completely doesn't work. So one thing that you need to solve is how do you build a system that knows how to do that effectively given the network constraints, right? So you don't combine feature vectors every epoch, but every X epochs. And how do you do that? That's too much and not too little. And then how do you actually also work on effectively doing that over a network? And then obviously do that from a security perspective, because again, you can't access the data. You have to make sure that when it passes through network, again, it's you can't get access to it. That's an engineering problem combined with a science problem, right? And so that's one aspect of what we do, and really figuring out and providing a solution that's very effective in terms of being able to deliver um, almost or the same results in terms of if I had trained the model with the data all in one location, and doing that in terms of an effective time and cost. The other piece of what we do is
And
how do
before we stray too far from that, how much of the results that you've seen there would you describe as MLOps and the process of moving data around versus I'm wondering if there's like an algorithmic component to this as well.
there is a data science component to this, right? In terms of you need to figure out how you combine those, the feature vectors effectively, how you actually send, when you will send that. That's a data science aspect to it. The the engineering around sending this data securely, effectively, fast is a pure engineering problem.
Okay.
I don't even know if you want to call it MLOps.
But you're getting it. You hit the nail on the head. There's aspects of both data science and engineering required to address this issue, and you can't do it without both
Exactly.
pieces.
And that's one piece. The second piece that we help, or that's fundamental to our federated learning offering, is the data aspect. This is what I call the hyper data sets. Before, this is the underlying aspect of. Okay, let's take a use case with let's say hospitals, right? Federated learning is a problem that a lot of healthcare is looking at a lot, because you've got data, you've got patient security, and in many aspects, the healthcare institutions don't want to physically have the data go out, even if they're allowed to. Uh, better safe than sorry, right? And so they would rather be able to have a solution where their data physically stays in their locations. So, but let's say you have a hospital in, in location that has a large Hispanic population, and then a hospital that is in a location that has a large Asian American population, for example, right? They may, they tend to potentially have different, diseases. Let's say genetic disease, for example. Again, and so, or maybe one location where you have more women than men, or where the population tends to be younger and older. And so, if you want to build a model, you have to take that into consideration when you're taking data from those different locations. One hospital, which may be skewed towards, a more elderly population, may have more data than another one. And so, to use that at a ratio of 1-to-1 or not. And so, for a successful model that's built off of federated learning model, you have to take that into consideration. And so you have to have a system that enables you to look at your data, at the makeup of your data, and at the skews and biases, and be able to rebalance that for training. And you need to be able to do that without seeing the actual physical data, because you don't have access to that. Which is essentially what we provide with hyper data sets. We provide an ability for people to actually balance the data based on those aspects without ever having access to the data. And then the system itself, when it trains, it knows how to balance the data to make sure that you're not getting a model that's skewed because maybe one hospital has too much data about elderly people.
The picture that I'm creating is like database or data warehouse views, and the views in this case are doing data science things like stratification and weighting and stuff like that. So the data scientist isn't doing that as part of their model development process. They're just kind of accessing a data set that's provided via this view that does that stuff for them. Is that the
Exactly.
idea?
Absolutely. We call it the data view. You hit on something really super interesting, Sam. When we were talking to our marketing guy to work on, how do they explain hyperdata sets and feature stores, and he's like, well, it's a
Mm-hmm.
data warehouse. Like, yeah, you're right. But for whatever reason, you tell this to data scientist, no, we don't work on data warehouse. We need to take the data out of the data warehouse and work on a feature store. No, it's a data warehouse. It's a database. You're absolutely right.
Yeah.
A lot of the features and capabilities that we provide in hyperdata sets are really essentially, it's essentially a database that was built and optimized for AI use cases.
Mm-hmm. And is that the feature store in your solution, or is that specific to this federated ML, federated learning problem, and you do something else for generic
Right.
feature store, if we can call it that?
We've divided. You can think of it as actually three layers. We have a feature store, which is basically a feature store, how everyone discusses it, data lineage, snapshot in time, being able to serve it for production or for training, being able to look at all the features. That's one solution that we provide.
Mm-hmm.
Then we provide an additional module that we call hyperdata sets,
Okay.
which is the ability to actually create those data views and identify the skews and have search capabilities within the data and then rebalancing it. And then the third layer is the federated learning system that takes advantage of that in order to deliver federated learning application or platform.
Got it. And on the feature store side, are you? I've got to imagine you come across the real time versus batch, and folks wanting to do both on a converged infrastructure. Like, do you have a take on that whole thing?
Um, we most of our most of our customers tend to focus more on deep learning, where that's less of an issue.
Okay.
Um, a lot of our customers in the machine learning space um, tend to basically use the feature store for development, and then when they're deploying it, they're just using the deployment server.
Mm-hmm.
And they're not necessarily connecting back to the feature store. There's by the way, there's overlap between feature store from that perspective, being able to deliver into deployment, and a lot of the deployment servers, even open source deployment servers out there that provide some of those capabilities as well.
Can you elaborate on that a little bit?
For example, Triton from NVIDIA
Mm-hmm.
provides a lot of the capabilities to be able to deliver data for inference optimally. And you don't need to go back and rely on a feature store for that.
Got it. Cool. I think we also wanted to talk a little bit about transfer learning. You're doing some cool stuff there. Maybe we'll spend a few minutes on that and finish up.
Sure. So one of the concepts that we've built around the experiment management piece, and essentially the whole platform is really a concept around. You can think about it from regular computer science, object-oriented computing. Basically,
Mm-hmm.
you want to create, or Dockers, right? You want to create containerized solutions, but that are also within them also have, encapsulated solutions, right, where they have a very clearly defined interface between them, so you can connect and remove pieces and connect something else without changing anything or needing to understand what's going on inside. This is how we think of an experiment. When we think of a task, we think of, okay, it's an object that includes the code as an object, includes the data as an object, includes uh, um, the model as an object, etc., etc. And then you have the artifacts, the logs, the results. All those are objects. And then you go into concept of what we basically call clone, where you can, with a click of a button, basically clone that object with all the ancillary, related objects connected to it. And
Mm-hmm.
what you can do now is start switching objects without having to go back to your underlying code. This means that you can very, very, very easily, you basically have the underlying structure for transfer learning, right? I want to build a model to identify X or predict X. Now I want to use, I have a model that predicts X. Why don't I use the same thing to predict Y, right? All I
Mm-hmm.
have to do is train it on different data. If you didn't have this concept, this architectural concept in design within the system, you would need to go back to your code and build that model. You have to now connect it to that specific database and that specific data set and its aspects. And there's a lot of work related to it. With ClearML, it's a click of a button. You clone that task, you clone that experiment. You basically switch the data set from one to another. You don't have to go back to the code, and voila, you can now run it.
Mm.
You have transfer learning. What we've gone even further is NVIDIA has a transfer learning kit. It's called a TLT, Transfer Learning Toolkit, that they have on their NGC cloud, that also provides a lot of pre-built models that you can transfer from. And TLT is now integrated into ClearML and comes out of the box. So not only can you
Meaning
use
all these
our
TLT objects or these TLT models are already built in your object format, and you can just plug your
exactly,
data in and
that's it.
got it.
Yep.
Cool. Very cool. Any thoughts on kind of how MLOps evolves over the next few years? How are you thinking about the market and where it's headed?
I think, first of all, I think that we're going to see more and more of MLOps. The dilemma of do I build or buy, etc. That's all going to disappear. It's all going to be, buy and build, or open source use and build. And I think that pretty much no one is going to think otherwise. We have to, there's a lot of maturity that needs to happen with a lot of tools. I can think of so many features that we have on the list that we want to build. And I think that one of the things that we're going to see with MLOps is that we're going to get through the maturity of the tools and the complexity on one hand underneath, but also being able to deliver it in a simple way. We're going to be able to get people to build stuff that aren't data scientists. And so today you have a lot of, I don't want to call it necessarily toy applications for people who are, have zero capabilities of building models. They work for very simple models, right? But I'm talking about the ability for a very specific, industrial application, right, in whatever industry that you have, to build something, but not need to have, an army of data scientists, and be able to have the business owner of that problem be much more integrated into the product development. And that's going to cut costs significantly. That's going to increase the quality of the work that companies are going to come out with. And I think that's all going to be delivered by more sophisticated MLOps tools on one hand, and on the other hand, being able to deliver those with simple interfaces that are easier to use, intuitive to use, and we're seeing the really beginning of that. Also, you going back to your original question on the timeline of when Google did the blog post and what happened.
Yeah.
We always underestimate as startups and technologists at the cutting edge of things. We we tend to forget that most of the world is behind. What we think what we think really as granted, we take for granted. Most of the world isn't there yet.
We're just
I
at
was
the
just
tip of the
talking to
spear, so to speak.
I was just talking to a customer earlier today. They're building solutions for the for defense, right? So they're going to use our platform and they're build a specific solution for defense. And he said that the one thing, the CEO there told me, when I go to these defense contractors, the one thing I can say that's common across all of them is when I go from one side of the door to the other, through that magnetometer, and they're going to check everything, and they're going to take, it's like I passed, through a time tunnel 20 years back, right? So, there's so much to do. There's a whole huge industry behind that needs to get up to speed on that. AI is really just scratching the surface, and MLOps is going to be able to deliver that to all those industries, and we're going to see that happening. Just that in the next 5 to 10 years is going to proliferate across all the industries. Is what we're going to see.
Awesome. Well, Nir, thanks so much for taking the time to chat and catch up and share a bit about what you're working on with everyone in the audience.
Thank you, Sam, for the opportunity. It was a pleasure. It's always great to talk to you. You always have very insightful questions. It's a pleasure.
Thanks, Nir.
All right.